if it tells us pOH is 8.63, then I know the exponent on 10 is negative 8.63. So I'm going to do shift log, and what I'm about to enter is the exponent on 10. I know it doesn't look like it. Negative 10 to the power of negative 8.63, and I get 2.3-ish. And don't forget that times 10 to the negative 9, yours may be out here, and everybody's forgotten that at some point. But I got 2.304 times 10 to the negative 9. Now, the other thing that people forget is that if you take the pOH value as the exponent, well, the negative of it, what you get is the OH minus molarity, and remember, brackets means molarity. So what I got was the answer for the molarity for OH, and it's really tempting to put it as the H plus, but it's not. If you use pOH, it relates to OH minus. So what I got was the answer for the OH minus molarity. Now, how could I get H plus? Well, back in my previous video, I said that this molarity times that molarity has to equal 1 times 10 to the negative 14. Therefore, 1 times 10 to the negative 14 divided by whatever you know must be the other one. So take 1 times 10 to the negative 14 divided by this, and it will generate that. Or, we do know another fact. We know that pH plus pOH must add to 14. Therefore, what I could have done is 14 minus this would give me pH, and then I could have said, if that's pH, then I could have said shift log negative 5.37 will give me H plus molarity, and look, I arrived at the same answer both ways. It doesn't really matter which way you use. So let's try 3. What's the pH and pOH of this solution? Now remember, this is a strong acid. This is a strong acid. So all the H's are going to come off. So if I could find the molarity of the HBr, I would know the molarity of the H plus. And they told me the molarity, didn't they? So we can just do this. We can cross out mentally the Br, and we can just say that this is the molarity of the H plus. How do we get pH? It's the negative of the log of the molarity value. So we'll take the negative of the log of the molarity value. 1.2 times 10 to the power of negative 3. And there is my, no E, no, no E. There's my pH. Now I know pH and pOH must add to 14, so 14 minus my previous answer must give me my other one. What if we know sodium hydroxide? Well, this is a strong base, back from our list, and all the OHs are going to come off. And so if I know the molarity of this, which I do, I know the molarity of either one of these because they're going to separate equally. Well, the sodium isn't going to affect my pH or my pOH, so let's just cross it out mentally. And let's say that this is the molarity of the OH minus. Okay? How do we find pOH? We take the negative log of the value. 2.3 times 4. 2.34 times 10 to the power of negative 5. We get 4.63 is my pOH. Remember, if we're going to use OH minus, we're going to get pOH. If they must add to 14, then 14 minus your previous answer is the other version, is pH. Talk about number 5. What's the pH and pOH? Right. Well, what do we know we need for pH or pOH? We need a molarity. What are we working with? Hydroiodic acid. Well, I know this is from a while ago, but that is HI, and that is in my list of strong acids, and all the H's will come off. So I have 15 grams of this, and if I could find the molarity of this, I'd also have the molarity of the H plus and the I minus because they'd come off equally. But I don't really care about the I minus. It's not going to affect my pH. So let's mentally just do this kind of after we get the moles. So 15 grams of this, huh? Well, what do I need? Molarity. What's inside molarity? Moles per liter. They told me the liters, didn't they? Because this is 2.500 liters. So what the trick is here is to find the moles. But we've done that about 100 times. I have the grams. I go find the molar mass, which I'm not going to review right now. I just looked it up, honestly. Divide gives me moles. This is moles of HI. What's molarity? It's moles divided by liters of solution. They told me meters of solution. So this divided by that gives me a molarity. And technically gives me a molarity of the HI. But like I said, this is all going to dissolve and all the H's are going to come off. So whatever the molarity was for this HI is also the molarity for the H plus, and I don't really care about the I minus, so I'm going to mentally scratch that out. Look what I have now, a molarity for H plus. How do I get pH? I take the negative log of the value of the molarity, and it gives me pH. pH and pOH must add to 14, so 14 minus my previous answer will give me the value for the other one.